All right, everybody. So Nathan here with our lead ML engineer, Jay. So he's going to introduce himself and try to explain the best he can what we've done so far with our LLM and machine learning work. So go ahead and introduce yourself and kind of tell people about your education and background.
Okay. Thank you, Nathan. Yeah. Hi, everyone. My name is Jay Kim. I'm a lead ML engineer in Devolved AI. I have like two masters in engineering and also physics. And I have like one bachelor degree in another engineering. I've been working in ML industry for about 10 years. So I have a lot of experience, especially for the federated learning. I have experience in utility domain. I have been actually working on some decentralized the ML for developed AI. And today I will just explain what I built for our company, just very briefly, so that everyone can actually understand. Let me explain like what is special for our federated learning. So, uh, so first thing is that this is a decentralized, so it's very secure. So no one actually need to send the data to us. Data will be trained in their local machine. And then we just get the weight of the model, and then the model will be updated in the central model will be updated from the weight from the local. So it's very secure, but there are many things, obstacles for federated learning. The first thing is that you have to, the machines are all in different area. So it has to be, network has to be very good. It has to be communicate really good with the main server and also local servers. Otherwise, it doesn't work. So our approach is that we are actually doing real-time pipeline between the main server and also the local machines. So in AWS, we use the AQS service, which is a messaging queue service. So it's a real-time pipeline. Now another thing is the main server, we use the containerization. So it's step function. And then we didn't actually use the actual server, it's just the container. So it makes them more flexible and also secure, and also a lot of the security problems solved, because no one can actually hack in the container. Even though they hack, they don't know, they cannot understand. There's no code. So yeah, so I prepared some the demo, and also this is architecture for the technical view. So each client have a different the machines. So they have their own local local storage, and also they have their own compute. So now we actually, I will show like we are using the local compute, and then we are updating this is the main area, the model is here, so you'll be updating the weight, and the weight will be saved in the storage in AWS. So those are what's going on, and also this is connected through the real-time pipeline, which is the SQS pipeline. So those are the brief architecture, and then these are a lot of the lambda functions, which is the serverless the functions in AWS. So the engine is actually lambda functions. So it's running in AWS cloud, and then it's actually communicating with all the clients. So if one client is down, then actually it actually stop kind of, because it doesn't have a signal. So when you actually create the container, we actually make the right numbers. I already created it, the container. So I can show you how it was actually created and everything in the demo. Yeah. Okay, so let's move to the machines. Yeah. So I set up 3 machines. Each machine have a different different network, different storage, different the compute, right? So and then the data is actually different too. Each computer has different data. So we will be using the different data in each client. So I actually create some of the container the same here. Okay, so I already created it. So you can see here. Yeah, so I actually set up as the client numbers as a 3. So because we have a 3 the machines, and also I set up some other parameters to be able to understand for the container. So once we actually create the container, you can change it. The container is already deployed in the AWS. After I created the container, I deploy the container the configuration here, and also I comment here. You can see the command line that I done. So this is actually also deploy the configuration, and also on here also I deploy the configuration, same configuration. So it's all connected to the AWS to the container. So now we can actually run each client for training. Okay, so this will be client 1. Okay, so I commented as 1, then running this locally to train. Okay, started running, but the thing is that it's only one client because I set up 3 clients. So you need to have 3 clients running at the same time, otherwise it doesn't run. But it's because I run this program, so it's actually waiting until other signal is coming, other parameter update is coming. It's still waiting. So you can see that here, the SQS messaging is actually waiting for other clients, the wait update. So it's actually the data is flowing, but it's only empty queue. So that's why it's waiting. So it's waiting until the other the queue is coming. So I will run another machine for client 2 here. Okay, so now my second client is up, so it's start to train. But again, this one is the second one, but I set up 3 clients, so this one also waiting another client queue. So, but the flow is actually real-time flow is already flowing on each machine. Then last one here. Okay, now we are running the third client. Oh, one second. Oh, it's breaking. Okay, so now actually it's running. So right now it's all the signal is coming. To try is everything is running at the same time. So one machine break, then the other machine will be actually don't have signal, so you'll be waiting the signal from the last the machine. Yeah. So right now 3 nodes is all running. So right now it's training each the machine. It's actually updating. It's communicating with the main server, which is actually serverless in container, and then it's updating the weight of the model, and then saving to here and the storage in the AWS. And it's keep updating whenever it's a training. Every epoch, every step, you'll be updating the weight in the meter or in the AWS meter storage. So you'll be saving the storage and then keep updating in real time. Yeah, and then we can actually monitor what's going on in the AWS the web page here. So I already inside of the AWS the website. So this is a step function. So everything you can track the what's going on here. So now I think this is the one that we are running. Yeah, so some job we already prepared earlier, but the job that is running right now. So if you go in and you can see what's going on. So right now we are starting here, and so it's going on. So whenever it's actually running and then it's going on, then you can see, you can monitor from the Amazon website. It's actually, and also all the history will be all saved, so we can we can track what was going on before in the training job. And then so this is what's going on. So right now we are training pretty big data. Of you, I mean it's not big, but it's pretty large. So which is about like 5 gigabytes each. So you'll be taking some time to train everything. Yeah, so right now, just one more thing. So I can show that we are running, we are training things. This epoch is here. Yeah, you can see the epoch numbers, epoch count. So it's only 2 epoch. I designed 2 epoch. The one epoch made of the many steps. So step means that I design batch. So you'll be bringing the data as a batch. But batch is not the whole data. It's just a certain chunk of the data. So you have to, if you want to have a one epoch, you have to get all the data, everything, which is a step. So step numbers are how many times you have to grab the data for one epoch. So it's pretty much, data is pretty big, so you have to grab a lot of the data, a lot of times. So epoch will be 326 steps has to be grabbed, and then you can have one epoch. So you'll be taking pretty long time. So right now it's only 54 steps for one epoch out of the 328. So so we have to wait until all the training is over. Okay, so this brief explanation about what's going on in the AWS cloud and also local machines. Any questions?
Yeah, can you explain to the viewers what makes this system that we're designing different compared to more standard and traditional AI at the moment?
Yeah, so standard AI, every AI, ML, and modeling has to have a data in one place. So if the data is not here, you cannot actually build any models or AI models. You cannot build it. So the first thing for the typical ML engineer do is that we collect all the data in one place and one table actually, and then we can train the data, and then we build a model. But the collecting all the data is pretty very hard actually, because many companies doesn't want to share their data for security reason. So it's almost like a lot of times it's impossible to collect all the data. But this method is actually, they don't need to share the data. They actually holding their data in their system. We just we train just so we send our the model to each client. We have an app, so we can they can just install our app. Then the model is already in there, and then we train each device, and then they don't send the data. They send the model weight to us. The model weight is just a bunch of the numbers. It's matrix, and no one can actually understand anything. And then it just update our the main the model weight. Yeah, that's it. So it's very secure, and also it's very reliable, and also we can do a lot of the things, even though there are a lot of the unshared data in the world everywhere. So we can just you can build any models with any data, even though the data is not centralized, right? So yeah, so this is a biggest benefit for our approach. And also there are many different federated learning approaches, but our approach is that it's more reliable and more scalable because we are using real-time pipeline, and also we are using container, so we can actually scale up really a lot. So for example, we can scale up to like 1,000 people at one. Not we can federate learning 1,000 clients in one time, kind of, so we can utilize big data, even though we don't collect the data. Yeah, so we have the good benefit than any other federated learnings. So we are planning to actually integrate the IoT technology, which is using lighter protocols like the MTQQ protocol, which is very light, so we can actually integrate many different clients, huge number of the clients, so that we can build a better model, more AI model, and we can move forward much quicker. Because other company, they have to collect all the data, it take a lot of time, the people never share. So if they want to build a very simple model, even simple model, they have to wait for a long time. But for our approach, we don't need to, they don't need to wait anything. It's just we can just go ahead, and then we can start to build the very good models for everyone.
And our model, this architecture will support the model updating in real time.
Yeah, real time. Yeah,
so compared to like GPT, which they have to do, it's not real time, correct?
Yeah, GPT 3.5, I think it's not the real time. They have to update it like every year, something like that.
And even GPT 4, they have to do updates, right?
Yeah, correct.
Ours can update constantly.
Yeah, we can update every second. Yeah.
Wow,
so it's
amazing.
It's real time. Yeah.
Okay, and then I think last, if you can just do one more summary about the container and why that's so important for what we're doing, how it's more secure using containers.
Yeah, so a good question. Yeah, container is actually I think everyone knows about Docker and Kubernetes. So container is actually including all the information in container, but it's not the I/O level. Actually, it's in I/O level. So, but the information is actually containerized and it's sealed with the container. So and then when we don't use it, the container is actually not there. It's just some index or some indication. And then when we actually trigger the container, then the container actually start to run kind of. So in the just normal time, it doesn't actually it's not there actually. The data or nothing is there. Even though the operation system is not there. It's just nothing. So even though the hacker actually coming in, try to find out something, it's not running or nothing. So they can actually find out.
So it can't be hacked.
Yeah, it can be hacked, but even though hacked, there's no information. They can actually see anything.
They can't see anything if they get inside.
There's no code, nothing. So code is so all the information, all the network, everything is actually information is actually in the container, but the container is a kind of some encoded information, so no one actually can see it. Even though they see it, it's actually they cannot do anything with that. And then because this is very flexible, I mean in IO the way, so it can be actually run any system, or even it's a actually Linux system can run on the Windows. So because many clients have different the OS, like the operation system. With the container, we can actually run any machines or any type of the machines. So it's pretty flexible, so security-wise, it's not actually sharing any code, so they cannot do anything, even though they hack.
Okay, I think we covered all the points, right?
Yeah. One more thing is for container, because it's actually running only when it's triggered, so it's actually very efficient in space-wise. So in the storage or some memory, it's saving a lot of the things. So it can be actually save a lot of money. Yeah. So because if you don't use the container, you have to run the server 24 hours, but it's very expensive.
So this is serverless.
Yes, it's serverless. Yeah. So whenever it's triggered, it just runs. So and then AWS charging only when it's triggered.
Oh.
They don't charge anything while it's not running. So they also, even though they charge, it's very cheap. It's a lambda function. It's very it's almost free almost. So it's very you can save a lot of money from there. So a lot of the benefit for being the containerization. The real time data pipeline is more stable with the container. So yeah, so I think this is the way to go. If you don't use the container, then real time can be very unstable. So yeah, so it's actually partner. It's a matching partner.
Okay. All right. Well, you did a good job explaining it all, Jay. So everybody, thank you for watching. And if you have any questions, you can go to devolvedai.com and reach out to us. Thank you.
Thank you so much. Thank you,